up where I left off. We were talking about describing all the transformations. In C, it was a horizontal stretch by a factor of 3, and the reason why it was 3 instead of 1/3 was because x over 3 can be written as 1/3 x, and so remember it's always the opposite of the number attached to the x, so then that's why it was a factor of 3. Over here we have a reflection. Oh, that's really thick. Okay. Over here we have a reflection over, when we made the x's negative, it's reflection over the y-axis. Okay, and then that positive 3 means it moves up 3. Lastly, when it's on the inside, it's the opposite, so we're going to move to the left 1. And then this minus 2 means we'll move down 2. So the same rules of transformation still apply. So don't forget this is going to be very helpful when you have to graph these, which is what we're about to do now. Vertical stretches affect the amplitude of the function. And the amplitude is half the distance between the maximum and the minimum values of the function. So another way you can think about it is it's half of the height of the wave. So in this diagram you have here, this orange line represents the amplitude. It's the distance. It's basically half of the wave. So the full wave goes from being up here to down here. So basically half of that distance is your amplitude. Okay? So if you can figure out what the max value is and the minimum value is, basically add it up, divide by 2, and you have your amplitude. Amplitude is always the absolute value of A. Sometimes A can be negative. It's the number that's in front of, it's the number that is in front of your trig function. And remember, when we're doing vertical stretches, if it's negative out in front, that means it gets reflected over the x-axis. So do realize that amplitude is always positive. So to graph a function that's in the form of a sine x or a cosine x, meaning there's a number in front, you multiply all of the y values by a, whatever a is, whether it's positive or negative, and keep the x the same. So the first thing we're going to graph is 1/4 sine x. So if we think about basic sine, right? At 0, we're at 0. We're at 0, 0. Then we're at pi over 2, 1. Then we're at pi 0. 3 pi over 2, negative 1. Then 2 pi 0. All of these, again, points are coming from the graph of sine, the original sine function. Okay, so if I were just to give a quick graph of what that looks like, remember, it goes just like this. And then we can also repeat it by going the other way. Okay, the red line is just the original sine function. We're just using that as a reference. So basically, all of my y values are going to get multiplied by 1/4. So it's going to be 0, 0 still, because 0 times 0, 0. But this pi over 2, 1 becomes pi over 2, 1/4. Okay, the y gets multiplied by 1/4. The one at pi stays the same, but the point at 3 over 2 now becomes at a negative 1/4, and then 2 pi stays at 0. So this purple line represents the graph of 1/4 sine x. I can repeat the same process over here on the negatives. No longer negative 1, I'm now at negative 1/4. 0, I'll stay where I am. Positive 1 turns into a positive 1/4, and then 0 stays where it is. So again, connect the points. And it basically is getting squished vertically by a factor of 1/4, and you can see that it gets closer to the x-axis. All right? So I want you to pause this video right now. I want you to give this one a try, okay? There is a negative 3 out front, so the negative means you're going to reflect it over the x, you're making the y negative over the x-axis, and then you're getting vertically stretched by a factor of 3. So to do this, remember, you take the y values and you multiply them by a. So a is negative 3. Pause this video, and I want you to do that now. So in the red, I got cosine of x. I'm just using that as a reference. So every point is going to get multiplied by negative 3. And I have the points listed down there. So all my y's are going to get multiplied by negative 3. So 0, Sorry, I had the wrong y values. I was thinking sine and not cosine. Sine actually starts at -1 or +1. So this is +1, 0, -1, 0, +1. So all these are going to get multiplied by -3. So 0, 1 turns into 0, -3. Power of 2, 0 stays where it is because 0 times -3 is 0. This -1 turns into a +3. This one still stays at 0. And this +1 turns into -3. Okay? And I can repeat that same process on this side. 0 stays where it is. -1 turns into a +3. 0 stays where it is. And lastly, +1 turns into a -3. And then this is the graph of -3 cosine x. Make sure that when you draw these, you try to draw the smoothest curve possible. Cosine is not my best curve to draw. Sine, I'm better at sine. And as you see, it's been vertically stretched by a factor of 3 and reflected over the x-axis. Horizontal stretches affect the period of the function. And the period is the distance between any two sets of repeating points on the graph of the function. So you can also look at that as basically from max to max or min to min. That represents the period of the function. So the length of one complete cycle or the length before the graph starts to repeat itself. As this diagram shows, in this particular graph, from here to here represents a period. Because after that second purple point, the graph is going to start to repeat itself. And that, again, represents the period of the function. Okay? You can also go from max to max if our x-axis was labeled, but we don't have that there. To find the period, though, say we're given the equation instead, to find the period, all we do is take 2 pi and divide it by the absolute value of b. Because do realize that b, if you think back to those original equations, is on the inside with the x, and it's always the opposite. All right? So when we're trying to graph a function that does have a b, does have something that affects your period, you're going to multiply all the x's by 1 over b. Okay? So do be aware of that. We're going to graph cosine of x over 3 now. So I want to take the points of cosine. Again, 0, 0, pi over, did it again. Thinking sine. 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, 2 pi 1. And you want to use like the big 5 because, again, it really does help you because they're going to be such nice numbers, especially the y's, and the x's aren't too bad. So all the x's are going to get multiplied by 1 over b. b is 1/3. Well, 1 over 1/3 is 3. So I'm going to multiply all my x's by 3. And as we see, my graph is not going to hold everything. Okay? So what we're going to do, I guess we'll still just graph it as it is. Okay? So here's cosine originally. And now we're going to graph cosine of x over 3. So 0, 1 stays where it is because you're multiplying your x's by 3. 0 times 3 is 0. But 3 times pi over 2 becomes a 3 pi over 2. So this point moves over here. And the first thing you're going to do is you're going to go from 0, 1 to 3 pi over 2, 0. Your next point would be 3 pi. 3 pi is located somewhere over here. And you're going to be down at -1. So this one's going to be all the way down there. So as you see, it's going to be stretched horizontally by a factor of 3, which means it's going to get bigger. And then you would keep going to get the others. Over here, negative pi over 2 is going to get stretched out to be a -3 pi over 2. And negative pi, -1 is going to be at -3 pi 1. Okay? So all of your x's get multiplied by a 3 to get the graph of cosine x over 3. Try this one on your own.